Okay, so today's it's very basics on top of data. So first slide is based on what is data. So data we all knows it's a collection of information and it describes, what kind of information we are handling in the data. Mainly describing the quantity, quality, fact, statistics, dimensions. So those are the things. What are fact, what are dimension, those things will be covered. Each of the terminology will be covered in the detailed session when we'll be touching those stuffs. So fact, what is fact? Specifically, will be focused on fact dimensions, how we can uh, categorize the data and store the data in each of the table. Those kind of stuffs we'll be covering after the, maybe after 1 or 2 days for each of the specific day. Okay. So, why the data are important? Okay. So based on the data, actually, each of the company, they're forecasting their business. So suppose, I'm owning a particular shop. Okay. I have 8 or 9 shopping outlets in my country in different states. So based on customers' choice and feedback, I receive the data from the feedback itself. The customers are giving the, information, what are they desiring things and what is the particular choices about for particular persons and all. And the source system are picking up those data by the entry method. Maybe the method, there is SAP installed over there. Maybe there are some Linux, mainframe system is there at the software, at the front end at their side. What the things they are putting in the UI, that should be captured as a data. The data we are receiving from that particular source system. So what data engineers are doing? They're compiling those stuffs and they're bringing those things to a meaningful data so that on top of data, meaningful things can be understandable. A meaningful trends or meaningful forecasting of the business can be understandable so that the uh, particular company can forecast their business or forecast their revenue in the next 5 months. Okay, so this kind of stuff. If their business is going down, they can quickly get what is the culprit for that one. Maybe a particular product, maybe some customers with the bad reviews and all. So what are the things they can quickly able to understand now with the help of data pattern, the input data itself. So that is why the data is very much important. And the data engineers, they are required for the flowing of data from the source system and to bring it a meaningful data into the data warehouse such a way so that maybe data scientist or any other specialized team, they can understand the data, they can learn the data, they can understand the pattern of the data quickly, and they can go ahead with their business strategy in the very next day. So that is why how the data is being required in the same enterprise for the future growth. Okay. So as I already mentioned, the purpose of data engineer, moving just to the next slide. So when you are going to be recruited for a particular company, the company, you can see it's mostly it's can be banking sector, it can be a commercial sector, it can be insurance sector, medical sector, pharmaceutical sector. So especially those kind of big sectors for their purpose, for increasing their business, they're going to recruit the data engineers, especially for the data analytics purpose, especially for the ETL2 specialization, especially for the cloud, cloud architect as well. So just like part you are also mentioning that you are a cloud architect, you want to be a cloud architect, maybe it's a very good role actually, but during the interview they can also ask, suppose you have covered the lambda function. Okay, I hope you have covered what is lambda function in AWS, correct? Part, or what is a
Yes,
step function? Yeah, but I
server,
think you
yeah,
but some
serverless
days,
servers.
yeah, correct,
Sorry,
those are
yeah, go
serverless.
go, go ahead. Yeah.
Yeah, those are serverless. But my concern is You know this thing, but you have used it with a hands-on with some languages and all.
No, no,
Okay.
no, I haven't used it. So I
Okay.
have knowledge, but I haven't implemented with like in any cloud system or any with any software. I haven't implemented. So that's my concern. That's what, like, I'm trying to figure it out how I can
Correct.
use that
Correct.
knowledge.
Correct. So specifically, if I am in your place, I should be having the same thing. But my main motto should be being a cloud architect. It's a very good role with very high pay scale. Okay. So, I mean, this is a very, I mean, when a project is being sanctioned, nowadays, I mean, they need to set up what are the different servers I need to take. So suppose I have a requirement that I need to flow the data from this source system to this target system. So how many EC2 servers is required? If I'm using any big data transformation, then what are the MR clusters? How the MR cluster size should be? What kind of EC2 I'll be using as a master nodes and a core nodes and all. So this should be very clear to you, but you need to know the data part as well because you are handling the data. You need to check the volume of the data in the source system too. Otherwise, you cannot determine what should be the size of EMR. Even as you know that lambda functions. So if you know I mean a Python language quickly on top of data, so suppose the serverless function means when we'll be learning Python. So in my same server, I will be installing a particular IDE called PyCharm or any kind of this any this kind of stuffs to be installed. And on top of that, I'll be learning Python. I'll be debugging the code on Python. But as part is award of the AWS Lambda functions and all, it's serverless means I mean AWS will be helping us with the server stuffs. We just need to put the command over there and we need to debug it with lots of facilities and all. There is a lots of option to input the input the particular parameters in that particular lambda functions and all, and to capture the output maybe in CloudWatch or any other stuffs, maybe using some uh, queue function, SQS or just like this. So part can use the data on top of that. So as a data engineer from the data perspective, how the infrastructure can be. So if part will introduce the same thing over here, then his profile would be, very much, attractive as well. He want to be a architect, cloud architect based on data. Correct, Parth, if I'm not wrong. I think you are planning in the same, if I'm not wrong.
Yes,
Okay.
yes, correct.
Okay, we want to integrate it. So you have the same kind of plan from anyone in your future, as Parth is already experienced a bit. So he's quite have the experience of knowledge how to integrate what is the open market positions and all. But the same kind of stuff that I mentioned. So you wanted to be a data analytics, you can be on top of data, you can be, get the hidden trend or hidden pattern on that by getting the role of data analyst, or you can be an ETL role. You can play the ETL role as well. So there also you need to focus on data. That is fine, but you also need to know how a cloud should be looking like. So you also need to gather the information of cloud because lots of the ETL tool are being used from the cloud. So that is also we need to know cloud to integrate our knowledge with data. You you maybe you can be playing the role as well as on top of a visualization engineer. So maybe you are working on top of the pure data. You want to move your career to visualization engineer means you want to prepare charts, graphs on top of the meaningful data or data warehouse. So suppose you want to work in Tableau dashboard and all. So you'll be preparing the dashboard to bring up those logics and to prepare those charts and graphs on top of that. So this is another way. So this is different way. Inside data engineer, we can uh, bring up our career such a way that we can go ahead with these things. And in the next batches, as I mentioned, that we will be introducing machine learnings and all. So there are also scope. If you learn this thing in basic and enhance your scope in future on top of data. Maybe data scientist and all. This role is also suitable. So there you need to know a bit mathematics always, but there's another scope to be a data scientist or artificial intelligence experts and all. Okay, but those are the various sectors, especially, I mean, people got recruited banking industry. They are checking the credit information, they're checking the debit information, they're checking how the particular customer is spending their money, and they can, and in the banking sector at that, I mean, they want to, at the banking sector, if I'm owning a banking sector, if I'm a CEO of a particular bank, I want to enhance my business, I want to capture some more customers in the next quarter. So how uh, this can be, I mean, how I can check their historical information, customer historical information. I should also have to focus, so that if any existing customer is leaving my banking system, so I need to also focus on that stuff. What is the reason my customers are leaving? Am I giving some very less, uh, I mean, that percentage of increment on savings account, or what is the purpose? If I'm not a good one, uh, uh, I'm giving the attractive offer to the particular customers. I mean, just like the competitors banking systems are doing, or this kind of thing, we need to analyze what I'm doing, what the markets, relevant markets are doing. So those kind of stuffs, each of the sectors they are checking, and for the same thing, data engineers will be helping them out. Okay, so that is why in enterprise systems, data engineers are required. Okay, I found Akshay joined over here. So Akshay, I think you already joined in the last session, correct? Last batch or last to last batch. I'm not sure. I just remember your name, recall your name.
Yeah, I think I joined 2 months back for 2 or 3 classes, and again there for some reason I didn't join back. So this is my first class again. I'm again into the
Okay.
pipeline.
Okay. Yeah. That is why I can recall your name. So
Yeah.
yeah, we just started the beginning of today's session. It should be the particular schedule should be same as it was covered in the last 1 or 2 days. I mean, last 1 or 2 batches. Just a few topics has been increased in the last batch onwards. So we have the hands-on part on top of big data, how to handle the big data and all. So this kind of hands-on stuff should be covered, and it should be done on top of Spark only, Spark or PySpark. Okay. So as part you have knowledge on AWS, you can also consolidate your knowledge. I mean, EMR cluster should be involved in a practical purpose, but I'm not using EMR clusters over here. I'll be, I mean, running the same thing in my local. The same thing can be done in Azure Databricks as well. So just if you have that knowledge on cloud for anyone, you can integrate your thing. Then the thing should be much more clear with the infrastructure as well as data. Okay. Okay, let's start with the stuffs what we have already started. This is how the enterprise data engineer should be working. What are the different aspects of the enterprise solutions? My next slide. Okay, so here it's starting with the bits conceptual stuffs. So the data representation, data can be represented in multiple ways. Here is an example. We are representing the data in relational database manner. This is called relational database. And this is the same data I'm representing over here. It's a non-relational database. In the relational database, we have to store the data in a tabular structure. In this tabular structure, there must be columns. Okay. The tables actually in the relational database, we need to create the data, or we need to push the data in a tabular format. There should be rows and columns. The column should be created first. Okay. And columns and everything should be created first, and if there is any new record to be inserted in the particular table, we need to insert them as a row. We should have to insert the record as a row basis. So the column should be created first, and that should be daily basis. Maybe today I have created the table structure is fixed. Okay, so in the table structure means the column names is fixed. The number of columns are fixed, but we are not sure what should be the records, what should be the number of rows of the tables in tomorrow. Okay, or after 5 years, what should be the record? Maybe the particular table I'm just storing the name and email for a particular company, for my company. So after 5 years, I'm not sure how many records should be inserted. Maybe my company has earnings a lot. I mean, even I am getting a big, I mean, a reputation. I mean, I'm getting a reputed company daily basis. So I mean, lots of employees are joining over here daily basis. So maybe after 5 years, there are maybe millions of I mean, customers, I mean, millions of employees has joined. Millions of customers are there for my company. So my particular data volume of that particular table can be millions or billions. Okay. So the row numbers will be increased for a particular table. The same kind of data can be represented over here. You can see it's called over here. Over here we are storing it as a column, and those are called records. Over here we are storing the data in a key value pair. So this is called key, name is a key, and RAM is value. Again, we have a key called email. This is a value. So this kind of storage pattern, it's called non-relational database. Why it's relational, why it's non-relational will be quickly coming into the next slides. But just to let you know, this kind of data storage, I mean, we have to store the data in somewhere, in some databases as well. So relational data, that means this kind of tabular structure data can be stored in relational database. Okay. So there are lots of databases available in the market. You might have heard about Oracle. You might have heard about Snowflake. In Microsoft, there is Microsoft SQL Server. There is Teradata. In AWS, might have heard Redshift. Okay, you might have heard Postgres, Aurora. So those kind of things, MySQL. So those are different relational database where we are storing the data. There are non-relational database available as well, which is storing the information in this. Just we have DynamoDB. Okay, in AWS itself. We have several kind of non-relational. If we are just writing a JSON file itself, JSON is a non-relational database. In the JSON, we are storing the data in key value format. Even if we are writing a XML, it is also storing the data as a key value format. Those are all called non-relational database. The main fundamental things, if we want to add a new columns over here. So as I mentioned in relational database, the columns number should be fixed. When it's created, it should be fixed. So it's a bit hard when everything is fixed. It's a bit hard to change the particular table structure, means include a new column over here. Not very tough, but as per the process we have already established with the manner, we are changing the table structure and all, we have to start the same thing from the development phase again. So we need to update the table structure, we need to remove those data, we need to insert again all the data with the new column. So that concept should be there. A bit hard with changing the tabular structure and insert the data. But in non-relational database, suppose it's very easy. Actually, we just need to include a key value pair. Maybe that key value pair is not required for all the row. Which row it's required or which particular records it's required, I can just quickly add it to this particular records. So there is lots of advantages and disadvantages for each of the databases. But for analytics purpose, as we are focusing especially for the analytics part, data analytics, and top of data engineering, we will be doing the data analytics things. So that's why we'll be focusing on relational database only in our next classes. We'll be learning SQLs and all. So we'll not be focusing much more on top of non-relational database. As of now, it is out of our scope for this thing. But I'll be just requesting you to quickly check what is the difference between relational database and non-relational database in some waves and all. If you are facing any stuck point, you can please quickly ask questions in tomorrow's session. So this is a kind of homework. It's not actually homework. We are all, working in we are studying in college, we are working in an industry or just like this. So just you can quickly check or brush up your knowledge. The difference between various key points, the difference between relational DB and non-relational database. Okay. Okay. Here is some few introduction. What is relational database? So relational database management systems store information in table. This table have shared information between them. So a database should be having multiple tables. A database means a relational database should be having multiple tables. And in relational, why it's called relational database? The tables can set up relationship between themselves. Okay. In the next slide, it should be very much clear how that can be possible. How two tables can be set relationship. So this is called relational data. That is why, we are storing those tables in particular relational database systems. Inside the relational database, the basic unit is of course a table. A table uses columns to define the information being stored and rows for the actual data. As I already mentioned it, table uses column to define the information. What kind of information I'll be storing? Just like username, user mail address, user postal code. So those are the different information I want to store. And rows of the table is the actual data. Okay, how many records or how many employees I want to store in the table, that is my actual data. Inside the data, there may be few columns, there may not be actually, but generally while setting up relational database, people used to create this kind of columns. So those columns are the identification of the particular row. Suppose in a particular company, you might have checked lots of employees are available. Yes, or maybe lots of employees are having the same naming convention. Means they have same first name, they have same last name. So how to identify that particular employee? That's why we need to create a particular identifier or particular column. We can create it on that table called employee ID. Employee ID should be unique. So a particular employee should be having a single employee ID. So that particular column employee ID is called the primary key. In the table, that primary key should be unique. That cannot be duplicated in nature. Okay. So that is called the primary key of that table. Like the same way we have the foreign key from other tables as well. I'll be just showing this thing in a pictorial diagram. Then it should be clear what is primary key and what is foreign key. And the main concept between primary key and foreign key. Next slides. If there is any stuck point from anyone, please tell me. Okay. Okay. So in the relational database, just to show you the relationship between tables, I have picked this example. I have the customer table over here. Just think about it. I am the owner of a particular company. I'm a owner of a particular shopping mall. So I'm storing the customer's information over here. So that particular information I got from the customer itself while registering a particular company's portal, or maybe while billing steps, we are taking the information from the customer itself. Okay, for some reason, it's customer ID is a generated column. For the customer table, you can see customer ID should be unique. For the customer table, customer ID should be unique. Over there, maybe order ID, address ID may not be unique, but customer ID should be always unique. A particular single entry should be there for a particular customer. Okay, so just I mean to say customer table, customer ID is the primary key. In the below section, in the order table, order ID is the primary key. Over there, product information is there. In the order ID, which kind of product he has purchased, he or she has been purchasing. In the below section, we have product table. Here is only product related information should be there. For a particular product being assigned with the product ID. So in the product table, product ID is the unique key. In the same order table, the product ID can be duplicated. Maybe I have order ABC. I have another order ID called BCD. But for the same, for the different order, maybe the customer has purchased the same product. That's why in order table, product ID may not be unique. Okay. So in each of the table, this is the primary key available, order ID. In the normal or natural convention, while the developers are creating those table, they are putting the primary key in the first column. Okay, first column or at the beginning columns, not first column. I can say there may be the scenario, maybe I can use multiple combinations of columns to bring up my primary key. Suppose there is two column, I am just consolidating and creating my primary keys. Just give me 1 second. Sure. Okay, so this is the thing. But in product in related information, so each individual product should be each individual product ID, their price, ratings, and all. So from the product table, product ID is the primary key. It should be unique. One product is being represented, one particular ID. So this is very important to identify the primary key. What should be the primary key for a particular table? Now just look into this. Suppose order table and product table. We have common column called product ID. Product ID is the primary key over here, and the same column is the foreign key to this order table. And by this common column, we can set relationship between these two table, order table and product table. Okay. So we have two different tables in database, order table and product table, but those tables cannot be isolated. Because suppose I want to know, suppose I want to know a particular customer has ordered something. I know the order ID of the particular customer. Now I want to check what is the particular products the particular customer has purchased. Okay. In the particular table, I have the product ID. Product ID means maybe some unique code, maybe 1, 2, 3. And particular date is there, the purchase date or order date. It's mentioned over here, but I'm not sure what is the data resides for 1, 2, 3 product ID. So for that thing to know, I need to check this table. I need to search with the key 1, 2, 3 over here, and I need to know the product name, their price, and their rating. There must be a column called product name. I missed it over here. So in the product table, I can get the information for product name, and I can place the same information into that table to map the information with order ID and product table if it's required to be known for a particular, maybe some data scientists want to know this, maybe some data analytics want to know this, or maybe a particular person needs to know what particular product that particular person bought it. Bought in from the market. To get this knowledge, we need to know this thing. Okay. So we are setting relationship between two or multiple tables with this foreign key and primary key concept. So this product ID is a common column, product ID is a primary key, product ID is a foreign key over here. While learning SQL will be learning the steps called join. So we can join multiple tables based on the common columns and fetch the data from other tables to this table to this table. Okay. So that is we can set relationship. Just like the same thing for customer table and order table. Customer ID is the primary key for customer table, and customer ID is the foreign key. Has the foreign key called order ID, address ID. Those are the primary key of each of the table. You can see order ID is the primary key of order table. Address ID is the primary key of address table. So we can set relationship between these primary key and foreign key. Okay. The concept is clear to everyone. What is primary key for a table? What is foreign key for another table? For the same table? Because this is the main thing, main fundamental stuffs. We are setting relationship between multiple tables. Those tables are not isolated. Those are not independent. One table is dependent on another table by this primary key, foreign key concept. We'll learn the thing practically while learning the SQL stuffs. But as of now, the concept is clear for everyone. Please let me know if there is any stuck point from anyone. No stuck point? Okay. Moving to the next slide. So this is the basic fundamental stuffs of relational database management system. Okay. Okay. Now for the relational database management system, how to traverse the data, that is called SQL. This is a query language, or language you can rather say, or we can also say programming language. If we are already having, IT or software background, so we might have know what is programming language and all. So this is a programming language to traverse the data inside the relational database. It's called SQL or SQL. So the day after tomorrow, we'll be focusing on that stuff. So over there, we are putting the languages to traverse a table. This is a simple example over here. Suppose we have a product table. Okay, we need to fetch some information from product table. So this is the way we can put the programming code to fetch the data from the product table. Okay, so it's called SQL, Structured Query Language, which is helpful to program on top of relational database management system. It's called a query languages as well. So this is the main technical stuff we'll be learning after a few days. And as I mentioned, there is NoSQL databases as well. So there, how to traverse data is called NoSQL. In the bracket, it's mentioned not only SQL. It's kind of database that doesn't use the tables, fields, and columns structured data concept from relational database. So by NoSQL, we can fetch the data from NoSQL databases. But I'll not be focusing this thing in the later chapters. Just to give you a basic introduction, NoSQL is this. And where to use NoSQL actually? In data analytics, generally we should not require this thing. But maybe we are integrating, suppose I'm creating a chatbot, okay? And there is ChatGPT, those kind of stuffs are available. So NoSQL actually it's very much faster to retrieve information. Suppose a chatbot is replying your answers. The answers, you cannot traverse a SQL query to find your answer. I'm asking for a question. In the backend, the particular ChatGPT robot is searching for the answer by firing the SQL query, it should take much more time to answer it. So there in the backend, they are storing the database in this format, in NoSQL format. Okay, when they are asking the question, they are quickly searching for it from the NoSQL database, and they are giving me the answer. So this is how NoSQL works, and this is one of the application in NoSQL. NoSQL is very faster than SQL databases. So NoSQL is been used to quickly get the information, but not analytics purpose. We cannot use it. Okay, analytics purpose, the main fundamental stuff we should be using the relational database, and that is why there is vast use of relational database, although it's a bit slow while traversing the data from the user interface perspective. Okay, so specifically this is a particular example of NoSQL database. Another big advantage of NoSQL is we can maintain hierarchical data. Just like over here, I'm storing the data in this way. Over there, you can see in the particular JSON structure, this is a JSON. First name is this, last name is this, is alive, a particular flag is been mentioned, age is there. Over there, I'm mentioning address. Inside address, I'm creating another JSON format. So it's a hierarchical structure. Okay. So over here, you can see phone number. Inside that, I'm creating an array. Okay. Inside array, because in the phone number, that can be multiple types of phone number. Inside the array, I'm just creating another JSON having different types. So for home, we have one phone number. For office, we have another phone number. Okay. So this kind of hierarchical structure can be easily maintained in NoSQL. It's very tough to maintain in SQL database. SQL, we need to parse everything. We need to flat the entire hierarchy, and we should be only one hierarchy over here. Suppose we have address. So let me show you an example. In SQL, when we'll be learning SQL, suppose address, employee name was there, employee address was there. Okay. So in NoSQL database, they're putting just like street name, pin code. So there, I mean, just merging this thing, margin center, employee address this. So in their representation, they are representing in this manner. Thus they are creating those hierarchy as per the no relational database. But while converting the same stuffs in relational database, will not converting in this manner. Will not be storing data in this manner in relational database. Rather, what we have to do, we do not have to maintain this hierarchy, or we do not have the scope of this hierarchy. We just have to do in this manner. We need to split employee address in twice. We just need to mention in the first column called employee address, rather we can put street address. The first column, in the second column we can put pin code. Okay. So it's again just like within address, we can put employee address underscore pin code. If there is any other thing, we can put in this manner. So the hierarchical way we cannot able to maintain this thing in relational database. It's good over here in NoSQL. So we need to flatten this thing. We need to flat this thing, and we need to introduce this thing in columns, this kind of columns only. This thing is understandable to everyone. I'm not getting any yes or no answer. I'll be just assuming if there is no response, so it's understandable from your side. Or tell me yes sometimes, then I'll be also, I mean, get some influence that I'm trying to show you in the proper manner and all, so the things are understandable. Okay, so moving to the next slide. Actually, today we have start a bit late. That's why the time is already over. I'm just taking this thing. So it will hardly take 5 or 10 more minutes to be finished today's session. So, okay, the next slide, it's representing of the same data by a chart. It's a line chart. So data representation of the same chart in this manner. So this is also a visualization of the data. As I was mentioning, there may be visualization engineer who can help with representation of this data by this kind of charts and graphs. Okay, so it's a data representation of the this kind of thing. So this is the ultimate goal as well, because user will determine, or the end user will determine the records or particular growth of their company by this kind of visualization manner. So this is one of the output that they can expect, the business owner can expect from the data engineers as well. Okay, basic example with MX Excel. Yeah, that is fine. We can quickly go through it. Okay. Let me open that sheet. Yeah, suppose I have a relational database, I mean a particular table. Okay, this particular product table is storing this information. What is the particular product? What is the price? What is the discounted price? What is the final price? Just I'm subtracting this and creating the final price. The same thing can be graphically interpreted over here in Excel as well. So what we have to do? Just we need to this is just a basic example, nothing but an example. I'm creating a bar plot, or I can create a line chart as well. Let me create a bar plot. So this is the data representation of bar plot. So you can see I can represent the data in this manner. Over there, I am grouping the stuffs over here based on each of the column called price, discount, final price. Each of the grouping stuffs we can see each color represents each of the product. Blue is cap, orange is board, and the third one is pen drive. Okay. So the same data can be represented in different manner. You can see the grouping stuffs over here is based on each of the column. So I can change the data representation with some more meaningful way. I can create the same thing. Insert. Okay. Okay. Last time the particular graph visualization is same, but the data is a bit different. Now we are grouping this thing based on product. So the first group is on cap, second is on board, third one is pen drive, and each of the bar is representing each column. This is price minus, okay, the big one minus this one is discount. The resultant should be this. So for a particular product, the third column is the final price need to be paid. So just like this. So from the same table, I created two different charts. Both of them are bar charts, but the data representation is a bit different. How we are grouping the data, how we are aggregating the data and represent the same thing in front of business user. This is also determine our efficiency of visualizing the stuffs as well as to understand the requirement from the user. The example I just give you that how the same thing can be differentiated by this, I mean, minute things. Okay. So maybe we are not, I mean, at the resultant, I mean, when the data is ready, the chart or report will not be prepared by the Excel itself because Excel will not able to handle big data. In the practical purpose, in the final table, there may be millions or billions of records. On top of that, we need to do this analysis. Analysis over here, we need to prepare the charts and graphs. Then Excel will not be able to handle this kind of stuff. There are several kind of tools, just like I mentioned, Tableau, Power BI available over there. So there will not be using this kind of stuffs. I mean Excel, but the concept should be same. The visualization should also matter in this way. Okay. So any doubt till now from anyone?
No.
Okay. Yeah, that's fine. So today this is the last topic actually. Tomorrow there should be day 2 of introduction. There will be checking the relational database, how I mean they can be normalized or denormalized. So this kind of stuff we'll be learning tomorrow. And the very next day we'll be going ahead with the technical and hands-on stuffs on SQL. And this is the basic thing for every data engineers that should be required one. Okay. So that's all for today. Let's connect tomorrow. But just check what is the difference between relational and non-relational database from any web or any articles from your side. We'll discuss the
Okay.
same thing tomorrow. Okay. Okay then. Thanks
Okay.
everyone.
Yeah. Thank you,
Yeah.
Suptik. Bye.
Yeah. Thanks. Let's connect
Thank you,
tomorrow.
Supti.
Thank you. Bye bye.